In Algebra 2, Section 3.7, we're dealing with Cramer's rule. Cramer's rule is basically another way of solving systems of equations. And systems of equations are the ones where we have two missing variables, two different equations, or three different variables, x, y, z, and three different equations, which in 3.4, some of you guys had a hard time solving. So Cramer's rule, and then our next section, inverse matrices, are going to help you use matrix to solve the equation. But before we go into Cramer's rule, we have to first know how to find a determinant. A determinant is just part of the equation for Cramer's rule. So every square matrix, so square matrix 2 by 2, 3 by 3, 4 by 4, has a determinant. It gets harder, increasingly harder, as you go from one to another. So the first one is the second order determinant, which we'll go over here, and then we'll go over a third order determinant, and then I'll introduce you to Cramer's rule. So the first one is basically I have a 2 by 2 matrix, and I'm going to multiply A times D, right? And then subtract it from B times C. It has to be A times D first. So first is top to bottom, then bottom to top. So A times D minus B times C. So basically I'm going to do 6 times 0 and then subtract that from 4 times -1, which would be 0. -4 times -1 is positive 4, which is 4. So my determinant is 4, okay? Which that value I'm going to use when I'm using Cramer's rule, but you'll see. But just so you know, that the basics is just we take this diagonal and multiply it, and then we take this diagonal and multiply it. And that's our 2 by 2, that's our second order determinant. Pretty simple. The concept is similar for 3 by 3, but it's just a lot more work, and let me show you. So go ahead and pause this and write it down. So a third order determinant has more numbers, okay? So we're dealing with more diagonals. And so here are the steps for us to do third order determinant, okay? The same concept, a similar concept where we're going to take diagonals, multiply them together, and then we're going to take diagonals the opposite direction and multiply them together, and then we're going to subtract all of them. So this is how it goes. The first step is to write the first two columns and to the right. So I'm going to rewrite this whole thing as 2 more columns. This is so we can get complete diagonals. Okay? The next step is I'm going to find the product of the diagonals. So the first set, I'm going to take diagonals from top left to bottom right. So this is my first one. I have to start from here and go down. So the first group is 3 times -1 times 3. I'm going to multiply these all together. So each diagonal I'm going to multiply, and I'm going to add it to the previous diagonal. So plus -2 times 0 times 1 plus -1 times 2 times 2. Or maybe we probably shouldn't have done that in blue. Okay? So basically, I'm going to go ahead and figure this out. So 3 times -1 times 3 is -9. And then -2 times 0 times 1 is plus 0. And then -1 times 2 is -2 times 2 is minus 4, which then I end up with -9 minus 4, which then gives me -13. This is my first. Okay? My second I'm going to find the diagonals. And I'm only doing 3 because this only has 2, so I have to do complete diagonals. So the ones with 3 complete diagonals are the ones I'm going to do. So the second set of diagonals, I'm going to go from bottom left to top right. So I'm going to go this way and multiply up. Okay? So then I have 1 times -1 times -1 plus 2 times 0 times 3 plus -3 times 1 times 2. Right? You see the diagonals, similar concept, but this is a lot longer than our 2 by 2. 1 times -1 times -1, positive 1, plus 2 times 0 times 3 is 0, plus -3 times 1 is -3 times 2 is -6, so -6, which then gives us 1 minus 6, which gives us -5. Okay? So then we go here. So we've done this, we've done these two, and then I'm going to find the sum of each group. That's this one, right? I added them together. And then the last thing I'm going to do, right, is subtract the sums. So I'm going to take the first sum. Oh, why did I go? It's 2. This is supposed to be 4. So I'm going to take the first sum, -13, and I'm going to subtract it from, so finally, I'm just going to put it here. I'm going to do first minus second. So I'm going to do -13 minus a -5, which is -13 plus 5, which is 8. No, -8. And that's how I find the determinant of this one. So I would use a second order determinant here to solve an equation with 2 variables, and I would use a third order determinant to solve an equation with 4 variables, and so on and so forth. This is not actually solving, this is just part of it so far. And there's an equation for Cramer's rule that uses both these determinants. So we're going to actually solve one now. So go ahead and pause the video, write this down. I have one more board. Okay, so Cramer's rule is basically, we're going to just do the 2 by 2. You have a similar equation in your book for 3 by 3, but to not make this video short, it's kind of similar things, except you're going to use the longer determinant for the 3 by 3. So, if I have an equation with 2 variables, x and y, and it's missing, and these are my coefficients, the numbers in front of them. We're representing them with letters, so they can represent any number. We have this right here, which is c, not the absolute value, but c. Okay? Whatever my c is, I'm going to take the absolute value of it, so that means it's going to turn positive. This is the determinant. I'm going to find the determinant. And then I'm going to find the determinant of the top and divide it, and it should give me the equation for x and y. All right? If that's confusing to you, let's go ahead and start it and see if it starts making sense. So I'm going to go ahead and put this into our determinant. It's our AB is 5, 4. So this is our A, B, this is our N, this is our F, G, N, without the letters, and without the X and Y. So 5, 4, 3, -2. So I'm going to find the determinant, which is 5 times -2 minus 3 times 4, which is -10 minus 12, which is -22. Okay, that's my C, big C. So then I'm going to plug it into the equation. X, let's find X first. So that means I'm going to find this matrix MB. So 28, 4, and then NG. So 8 and 2. All over the absolute value of C. So the absolute value of -22. So I'm going to find the determinant of that, which is 28 times 2 minus 8 times 4, right? The diagonals, all over positive 22. 28 times 2 is 56 minus 32 over 22. 24 over 22, which is 1.1. That's my x value. Now, you're wondering why am I using such a long process to solve this when you can use elimination substitution? Well, when we get into higher order, it becomes more difficult it becomes longer and longer. That's why matrices come in, but you need to be able to see it in this level of an equation. My next one is y is AMFN, so 5, 3, and then MN, 28, 8, all over the absolute value of negative 22. So this would be 5 times 8, yeah, 5 times 8 minus 5 times. Oh, I knew there was something wrong. This is supposed to be a negative. And this is supposed to be a negative. My apologies. That's why I've been kind of like, can't figure it out. I figured out my mistake. So this would be negative 56. So negative 56, it would be negative 88. So this would then be 4. Right? Perfect. I was wondering why we got a decimal. I was really nervous. Okay, got it. So, see how a negative can really throw you off? Okay, that's my lesson. So 5 times 8 and then 3 times 28 all over the absolute value of 22, which is positive 22. So we have 40 minus 3 times 28. Which is 84 over 22. Do you have a negative? Yeah. Which is negative 44 over 22, which would give me negative 2. So my x is 4, and my y is negative 2 for these equations. And that's how Cramer's rule is helping. So hopefully that made a little more sense. Go ahead and write this down. Try page 194, number 14, 194, number 14, and I will see you in class.